scuba diver is 400 feet below sea level and raising at a rate of 4 feet every 3 seconds. First thing we have to do is write an equation to represent the depth of the diver, letting y equals 0 represent the water surface. Okay, so the first thing I know is that this guy starts out below the surface, below by 400 feet. That means I'm going to start with negative 400. That's where he starts from. Then he's raising, he's coming up, so I'm going to be adding 4 feet every 3 seconds. I'm going to use x represent the number of seconds. Once I have my equation ready to go, I'm ready for part B, which says sketch a graph. So I'm not exactly sure what my scaling is going to be yet. I could make a table, but I'm going to try using y equals mx plus b strategies and also the intercepts to help me get a good accurate graph. Well, the first thing I know is that I need to go at least down to negative 400 for my y values. So my y-axis is going to have to be, oops, that's pretty ugly. It's going to have to be pretty long so that I can go into a negative area, or quadrant 4. X I'm only going to do in the positive direction because x represents time, and we only have positive time in the real world. Okay, so if this is the diver's depth in feet, he starts at negative 400. I'm just going to choose to have each box represent 20. So I have 20, 40, 60, 80, negative 100, negative 200, oop, 1, 2, 3, 4, negative 300, oops. Wait, I'm going to try that again because I scaled incorrectly. This happens all the time. You guys, a lot of times on your graph paper, it's so important you use pencil because you do the mistake I just made. I ran out of space. So instead of having each box be 20, I'm going to say each box is 25. That way I can go 100, 200, come on, I hope it fits. There's 300, 400. See guys, even brilliant mathematicians like me make these kinds of scaling errors. Just be really careful that before you get too committed to your graph, you have it properly scaled. Okay, so I know he starts at negative 400 feet. The next thing I'm going to have to do is figure out how to represent my slope of positive 4/3. Before I can do that, I need to put some scaling and numbers on my x-axis. So let's see, I'm going to have, I don't know, I'm just going to pick to do the same scale. You don't have to, but I'm going to choose to say again that each box represents 25. 1, 2, 3, 4, 200, 300. And I'm going to stop there because I ran out of space. I might need to increase my graph, we'll see. Okay, so starting at negative 400, I'm going to go up 4 over 3. And this will work for my y equals mx plus b strategies because I have the same scale on both the x and the y-axis, meaning I skipped by the same number of lines. Like a box here was 25 on this axis, and a box was 25 on that axis as well. So let's go through, oops, and using my y equals mx plus b techniques, I'm moving up 4 over 3. 1, 2, 3, 4 over 3. Okay, I have a pretty good looking line, I think. Okay, that represents the diver as he's coming up to the surface. One thing before I move on, I noticed that I forgot to label my x-axis. Please, 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 especially when you have a real-world situation, make sure you keep, oops, that's not feet, make sure you keep everything labeled so you can keep track of how y represents feet, x represents seconds. Okay, so when the question asks me to sketch a graph, I'm all set. I used y equals mx plus b. Part C says find and interpret the x and y intercepts. Okay, well you know the y-intercept is where the graph crosses the y-axis. There it is right there. Let me mark it in a different color. This is my y-intercept right here. My y-intercept is 0, negative 400. That's where the diver is right now. Where he is now. Okay, now I need to find my x-intercept, where my line crosses the x-axis. There it is right there. It's the point 300, 0. Think about what that means. He used to be 400 feet below the surface. At this point, he gets to 0 feet below surface, or he hits air. So when I'm asked to interpret the x-intercept, I'm going to say this is where the diver reaches the surface, or when the diver reaches the surface. When the diver surfaces. And this is really useful in real life because if you were on the boat and you were waiting for that diver guy to come up and you couldn't contact him but you knew how fast he was moving, you would know that he should get to the top after about 300 seconds. This is the kind of situation where a real-world problem can be modeled using a graph, and if you do it precisely using a ruler to help you and using the x and y intercepts, you can make some